guys, how are you? So today we are solving this problem, AllOne data structure. So this is basically all operation one data structure, you can say. Okay, so what is happening is, let's read the question. Design a data structure to store the strings. We are storing or decreasing, everything is happening only with the string as a parameter. So count with the ability to return the strings with minimum and maximum counts. So basically we have to find the frequencies of whatever string we are adding or decrementing. So we have, these are the methods. So this is our AllOne class. So this would be our constructor. So in this constructor, basically we have to initialize whatever data structure we're gonna use here. But we will read about next method. So this is inc, and it is taking parameter string. So this basically is a increment the count of a string, okay, by 1. So let's say we are calling this function of, so if a string is coming very first time, its count would be obviously 1. If it has already occurred, then we will increase its count by 1. This is very simple. Okay. Similarly for decrement as well. So decrement, when we are calling decrement function over certain string, its count basically decreasing. If let's say string is came 4 times, and then we are calling this function decrement on for same string, then its frequency would be decreased by 1. If it came only 1 time and then we are calling this decrement, it will make it 1 to 0, right? So simply just to decrease the frequency by 1 every time when we call it. Then we have the next function, getMaxKey. So getMaxKey would be return the string which is the having highest count, means the one which having the highest frequency so far. Okay, so let's say some string s1 came 3 times, s2 came 5 times, then s2 would be our answer here. getMaxKey. Similarly, getMinKey is the frequency of the string which came a minimum number of times, having the minimum frequency. So the special thing is we have to implement all these functions in time complexity O of 1. Okay, so these are all our methods. So far we are clear with the question. We should not have any doubt. Now let me go ahead that what could be our approach. We will keep it very simple. So guys, I am using the data structure here. I am basically using 2 data structure. One is doubly linked list and another is the hash map. Now we will discuss why all these, what is the uses of them. Okay, so this would be like my, let's say whatever doubly linked list I am using, these would be my nodes. So first one is head, okay, and last one is tail, head and tail, right? Simple. So whatever node from here comes to me, all will be only between these 2 nodes. Okay, we will have a class node. And this class would be having like this class node, every node would be having like a set of strings, okay, set of strings and frequency. Okay, so all those strings which are there in this set would have the same frequency. Okay, so we have one set of a string, then we would have the frequency, okay, and then we have 2 pointers, right, previous and next. Right, this happens in a 2D, I mean the doubly linked list. So we have these smallest thing, right? So we will have a set of strings and the frequency. So this set would be have all the string. Let's say string s1, s2, s3 all have frequency 3. So they will reside in the same node with that frequency. And this is the previous and the next node for us. This would be our class structure of all these nodes. And these nodes like head and tail, these are some dummy nodes with value 0. Initially I have just started with, which are connected to each other like this. Okay, they are connected to like this, just a single doubly linked list. Now whatever new nodes comes, we will add between them. So you would have got the idea that what would be our node, what we gonna store it. Okay, now we will proceed ahead, how to proceed further. And the next data structure that would be having is like hash map. Okay, so what that hash map basically having, so that hash map would be made of string and the node of this linked list, right? So key would be string and the value would be node. This would be our hash map. Okay, so it would look like this. These would be the values, string key and value is node. Now we will take one example that how everything would be proceed. Okay, so let's take one. So see here, this is our input. Okay, so first one is AllOne. Okay, so when AllOne comes, basically this is to initialize our constructor, right? So we don't have to do anything because anyway we will write our class. Okay, now our first thing is like increment method is being called with the value hello. Okay, so first of all we will check whether hello is there in hash map. This is our hash map. Let's say I'm calling its name is hash map. So is hello exist there? No, it doesn't exist. That means if it doesn't exist here, that means it is also not there in the our linked list, right? So that means it is coming very first time, because if something is not existing at all, that means its frequency is it's coming very first time. So it would become, we have to make a node then. Okay, so what that node will consider having, that node would be having the set of strings and the frequency of it and previous and next that we've just shown, right? So we will create a node here. So see here I'm creating a node because our hello is coming very first time. Okay, so its frequency is 1, right? And its set has only right now only hello, right? Because our set would be set of strings. So right now it has only hello, consider like this. Okay, so I'm calling this node 1, let's say n1. Okay, so we are adding this here. So hello would be stored here and head dot next would be becoming this, and this n1 dot previous would be becoming this guy, right? And this next would be our tail one, right? This dot next, and its previous would become whatever this n1, right? So we are clear so far, and we are putting this value. So hello came here. So in our map we are adding it. Hello came with what node? It is stored in n1, right? So far we are fine. Now there is one more input is coming with increment value, and again it is hello only, right? So we will go to this hash map first. So okay, is this hello exist? Yes, hello exist. So if go to hello, we will go to n1. Okay, so n1 is here, right? In linked list n1 is here. We will check what is the frequency. Frequency is 1. Okay, so frequency is 1. So our new frequency would become what? Whatever frequency we has in the node plus 1, right? Because it is increment, right? So anyway the existing frequency would increase by 1. Now you can see that this guy is only for the values f equal to 1. So we have to move this hello to somewhere which has the frequency equal to 2, right? So we will check on the right side. Is there some node already existing which has a frequency 2? No, there is no node. That means we have to make a new node of the frequency 2, right? So I'm creating this node. Now frequency would be 2 and our set would be having hello, right? So we created this node. Okay, but see here we have to remove this hello because it should not with f1 anymore. Okay, so I'm removing it from this node. So let me remove it. So if I have removed it, this set would become empty, right? Because only hello was there. Now this set is empty. Okay, now we have to do this dot next would be anyway this guy, and this dot previous would be like this, and this dot previous would be this, and this dot next. This is what will happen, right? But you guys check one thing here. Okay, that this guy f1 is no more required because there is no string which has having frequency 1. So there is no point of keeping this guy here. So whenever this set is empty, I have to remove this node from here. So I'm removing it. So I have removed that node, and this would be like its head dot next would be this node. So I'm calling this guy as n2. Now we are fine so far. And same thing, we have to update this hello because now hello is pointing to n2. So right, so we have to make hm dot put hello to this n2, right? So this is what now become. Now suddenly it came getMaxKey. Okay, so when getMaxKey is called, what we have to do is basically this getMaxKey would be there at tail dot previous. Okay, so what is the tail dot previous? it is this node, okay, n2. So what is the frequency? Frequency is 2. So whatever there inside this node in the set, we have hello, right? There could be multiple strings as well. We have to return only one of them. So we would be returning here hello. So hello would be our answer for this getMaxKey. Now we have again getMinKey. So min would be always next to the head pointer. So head.next. So what is the head.next? Again this also n2 because we have only one node. So here also what is the string? It is hello only. So both time it would be written hello hello only. Okay. So we would have some more examples as well which will cover further different scenarios. Yeah. Now we are again calling the increment method. And what is the value? This time the increment value is the leet. Okay. So we will go into our hash map. So hey, is there leet? No, there is no leet. That means we have to create this as a new node. And if something is new node, that means it has frequency 1. Okay. So because this is coming very first time, it doesn't have any value in hash map. That means its frequency should be 1. So next task is we have to find, is there some node which has the frequency as 1. So anyway, all those having frequency 1 would be next to head pointer, right? Because frequency 1 should be here only. But see here, when we go to head.next, this is actually a 2 frequency, right? So that means there is not at all any node which has a frequency 1. That means we have to create a new node of frequency 1. So let me create a new node and insert it here. So I created a new node having frequency 1 and then it sets only one value, this or leet. Okay, so leet only I have added in this hash map. Now we will add this head.next equal to this guy. Okay, and this dot next equal to this guy. We can just simple add method we will write it, which would be make the things very clear. Okay, so now this would be look like this, and same thing we have to put it here. So now our leet would be go to here. I'm calling it n1. Okay, so leet would be mapped to n1 in hash map. Okay, so you guys can see again we are getting called here getMaxKey, right? So getMaxKey is nothing but the tail.previous. So tail.previous, this is the node. So what is the frequency here? 2 is the frequency. So what we have to return? Whatever there in the set. So we have to return here string hello. So hello would be our answer for this getMax. Okay. Then we have next getMinKey. So what would be the getMinKey? getMinKey would be reside.head.next. Okay. So head.next is n1 node. So what is the frequency here? Frequency is 1, which is minimum. So whatever string we are having, so we have leet here. So we would be returning leet here for min. Okay, so we are done. So for maximum, we have to return tail.previous dot, whatever there in the set, one string only. And for minimum, head.next dot, whatever there in set, one string only. Okay. So let me add in this question few more inputs, so that our things would be very clear for other scenarios as well. So consider I am removing these inputs now, would be adding some more inputs in this existing stuff only. Okay, so I am removing these things. Now let's say somebody calling again increment method with the string sweet. Okay, SWEET. Okay, now what will happen? First of all, we will go to this hash map. Does it contain sweet? No, it doesn't contains. If it doesn't contains, that means sweet is coming very first time. So its frequency, it should reside in a node which has frequency equal to 1. And you know that frequency 1 are the nodes which are just next to head.next, right? So head.next is n1. So our sweet would be go to n1 only, right? So we will just add here. Okay, SWEET, sweet. Okay. We added this frequency is as it is. Now we have two words which having same frequency, leet and sweet, both have same frequency. So we have to update here also. So what we will do is we will update it sweet and it is pointing basically n1, right? So we are fine still here. So at any point of time, if somebody is calling you maximum and minimum, that should be straightforward. If for maximum we can return tail.previous.frequency, and for minimum we can return head.next.frequency. This is as simple as that. Now let's say somebody is again calling inc with the suite only. Okay, inc with the suite word only. It's the same function again being called, right? So what we will do is we will first look at here. Is it exist? Yes, it does exist. Suite equal to n1. So we will go directly to n1. This guy is n1. We will look for the frequency. Frequency is anyway 1. So whatever is frequency here, we have to make +1, right? Because this is a new value that we have to add. So what will become? Frequency would become 1 plus 1. So new frequency would become 2 for this suite. Well, now we have to look for the nodes which are having the frequency equal to 2. Okay. So we will check on the right side, because even the increased frequency has to be somewhere on the right side. But it not necessarily that it should reside on the next pointer itself. It may be or may not be, because see here, what if hello was deleted 2 times, right? So that not necessarily that it would always found here. So anyway, in this case we will check first of all, this is our node where our node is residing. Then we will look for the next pointer of it. So its next pointer is n2. And what is the frequency of n2? It is f2. Frequency is 2 and our frequency is also 2. That means this suite word we have to remove from here and we have to add it here, because this is now going to the group of frequency 2 strings. Okay, so see here, I have removed this and I am adding this suite here. Okay, I am adding this suite is now coming to upgraded to the frequency 2 group. So this has now leet only, and here also in suite we have to update because now it is pointing to n2. So let me make it n2. Okay, now consider a situation that decrement comes suddenly. Okay, decrement with the hello. Okay, decrement with the hello came, then consecutively we got also so let's say decrement hello came. So what we will do, we will remove this hello from here, right? And it has to go to the frequency 1. So we will add hello here, right? We will add here hello, and it would be removed from this group, and here hello we would update its this guy as n1, right? But yeah, so this guy would be n1. Now we have only here this guy f2 has only suites, right? Like this. Now it has only suites in the f2 group, but see here n1 has 2 guys. Now this is n1 basically. Let me correct it, otherwise this might confuse. So this would be our n1. So now our all things would be look like this. See here, in f1 group we have leet and hello, in f2 group we have only suites. Okay, now suppose somebody called this increment method with string boss 3 times. Okay, so first time it will go here, right? Then we are again calling increment, then we will remove it from here, it will go here, right? Because it will go to group 2. Then third time it will remove from here also, and this will go to new group which has frequency 3, right? So what we will do, if it is being called 3 times, our final thing would be look like this. See here, it would be look like this, and here we will write it boss, BOS. This would be representing, let's say I'm calling it N3. Okay, so I'm calling it N3. So clear so far? Now suppose one more situation. Somebody calls decrement 2 times with the value suite. Okay, SWEET. Okay, so if 2 times we are calling decrement of suite, what will happen? First time its frequency would become 1, so we will remove it from here and we will put this suite here, right? Then we are again calling decrement on the suite, so we will even decrease from here also this value suite, right? So finally it would look like that there would be no node which has f2, so it would look like this. So nodes would be look like this, because 2 time decrement would of the suite will remove everything from the n2, right? And we have to also remove this guy from here. So I am removing this guy from here as well, because we don't have suite anymore, right? So our final thing would be look like. Okay, now you guys can have observed one thing. We got a situation where see here, this is f equal to 1, but its node, next node having frequency equal to 3. So now we can visualize that there would be the cases when next node doesn't necessarily having the frequency increase by 1. See here, after doing these all operations, we found a situation that this node n1 has frequency 1, but its next node has frequency 3. Okay, so now let's say again they are calling increment on suite. Okay, so we will go here. Does suite exist? No, it doesn't exist. That means its frequency should be 1. So one frequency are there on head.next. So we have to add suite directly here, right? We don't have to do anything. We have to add suite and frequency is already 1. So we have to add here also. So suite, which is pointing to n1 only. Okay. Now somebody again called increment on the suite itself. So we will go here. Does suite exist? Yes, suite exists here. What is the node? Node is n1. So we can go directly n1. What is the frequency? Frequency is f1. So our new frequency would be f1 plus 1. So that should be 2. So we will go to next node. So this is our next node, n3. Does it frequency have 2? No, it doesn't have frequency 2. That means we have to create a new node of frequency 2. Okay. So what we will do is creating a new node of frequencies 2. So this would be our f equal to 2, and our hash set would be having the this guy suite. Suite would be there. This is suite. This would be only value in this hash set, and this would be the next, and this would be its previous. Okay, and this guy, this dot next would be there. So now this would look like this. Okay, and the suite would be pointing to n2 now. So remember, there could be these all situations. That is why we are taking this example. And every time that is simple, that whoever wants minimum value, return head.next.frequency. Whoever wants max value, return tail.previous.frequency. This guy having max value and this guy have min value. This is what simply we are doing, and we are using these doubly linked list because in linked list we can do the deletion and addition of any node in O of 1. Okay, so for that reason we are using doubly linked list and hash mapping to find that you have just seen, right? We have to map a mapping between the string and the node where it is stored. So this is simple what we have to do. Now I will show you my corresponding code and would be explaining each and every line of it. So as you can see, this is our node class. We are creating here frequency, previous, next, and the set of strings, right, that we were storing. Okay, so this is our simple that node class. Now we are coming here. So see here, head and tail I have created, right? I was doing these head and tail are our fixed thing, right? We are doing all the operation between these two. So head and tail with the value 0. Okay, these had 0 value only. They are not storing anything else other than 0. Right, so initially we have only these two nodes, so that is same thing I'm doing here. Okay, see, I have just connected head.next and tail.previous equal to each other. Okay, then we are going to the increment and decrement method. See here, this is our increment method, inc, okay, on this string. So see, first of all we are checking in the hash map. Okay, in that same hash map we were checking, then we are looking for it, that node equal to str to node map, whatever map we had, right? So we are getting this node, and from this node we are extracting the frequency in case if it contains. Okay, I'm coming to that point as well. So let's say it contains already, so we will get the frequency from the node.frequency, correct? So now what we are doing, anyway we have increased the new frequency, so that means it has to go to some higher frequency node, right? So we are removing this string from the set, just we did here, right? We were removing whenever something, let's say hello called, then we removed it from here and put it to here. So same thing I'm doing here. Okay, I'm removing it from the string, and so we are going here, next node is equal to node.next, whatever node we found we are going for the next of it and checking if this guy has, if this guy if it is tail, that means there is no node to right side, or its frequency is not equal to frequency plus 1. Just we had a situation, right, when n2 was not there, we had the f3, frequency was 3, right? So for same scenario, so when frequency was 3, right, it was not matching. In that case what we were doing, we made a new node, right, and we added it here. We are just doing this as an add function. So new node dot str dot add key, right, whatever new node we are making, we are adding it to the set of the new node, right? We usually add the things. If let's say we are adding one more time, then we will come to here and add it to this this set, right? So same thing I'm doing here, and I'm updating it the values to our map, okay, for the new node. This is all happening when we have already found it, when string was already there. But there could be a case when string coming very first time, right? At that time it wouldn't be available in the string, in the map, sorry. So what we are doing here, see here, next node, whatever next node would be there, we are adding it to that key. Okay, next node would be node.next, right? So we are adding that key, and then we are updating it into that our this thing, our map, right? Now see here, after removing the node where it was residing, we are checking, is there any case that our string set is empty, the older one? If it is empty, we are deleting it because there is no point of keeping it. You remember we had once f1 was deleted because there was no more string available, so we had deleted that thing. So same point I am doing here. If this string dot is empty, set is empty, that means we delete it, right? Otherwise what will happen? If it is not empty, then we will just remove our string and keep it as it is for other values, right? Because anyway every node has frequency and the set of strings which has that frequency. So far whatever we are explaining, this was happening if it is there in the hash map, okay. But if it wasn't there in hash map, then we will go to the else part of it. This is else part of it. So see here, I'm creating the first node. So I told you that the one which is coming very first time, it would have the frequency equal to 1, and frequency 1 node are always has to be head.next, okay. So head.next, we will get this first node. Now we will check whether this guy first node has frequency 1 or not. If let's say this first node is tell itself, that means there is no node at all, that means we have to create a new node. Or if the first node has frequency greater than 1, that means this is also not our thing, because anyway we are adding first time, so we need a node which has frequency 1. So if we don't have such node, that means we have to create a new node of frequency 1, then we are adding that key to the string, and then we are adding that that thing into our linked list. Otherwise, if this is not the case, that means if next node has the value equal to 1, then we don't have to anything, we just add the string to the set, okay, and update this thing in our hash map key and the node, and that's it. We are done with this. This is a void function, so we don't have to return at all anything, okay. Similarly, we have decrement as well. Decrement also we did, right? We did a lot of time dec called, right? So decrement is also same. So first of all, whatever string we want to decrement, we have to check it if it contains there or not in hash map. If it doesn't contains, that means there is no point of decrement it at all, because this is 0 time games, you return it as it is. But if it contains, that means there must be some node. So node we can get it from hash map, and then from that node we are removing that string, just we did, right? If we decrement this guy, let's say we are decrementing this lead, then we have to remove it from this hash set, right? So we removed it here. So if frequency is yeah, so see here, we will check here what was the frequency for the decrement key. If it was 1, if frequency was 1, that means we are decreasing it by 1, it will become 0. That means there is no point of even storing it in our hash map, right? Otherwise, if it is not 1, that means it is greater than value. So what, let's say if frequency was f was 4, right? That means we have to decrement it from the node, and new frequency would be 3. So we have to find a node which has the frequency equal to 3, right? So we will add our this value into those frequencies which has the node frequency equal to 3. Okay, so same thing what we are doing. So if it is 1, then we are removing at all from the even map. Otherwise what we are doing, we are taking this or the previous node of it, because the smaller value has to be reside on left side of it. That is why we are looking for the previous node of it. So we got the previous node of it. Okay, then we will check that is the previous node equal to head. That means there is no node at all on the left side. Or if previous node dot frequency is not equal to frequency minus 1, because we are looking for only those nodes which has frequency minus 1. If both these conditions are true, that they are not equal to frequency minus 1 or they are equal to head, that means we have to create a new node. That is why I have created a new node of frequency minus 1 and then I'm adding it. Okay, but if other case was, but in the case that our frequency, we found the previous node itself having the frequency equal to frequency minus 1, then we are coming to this else part. So nothing, just adding it to the hash set of that node and I am updating it in the map that now our key is actually pointing to this node, prev node. Okay, so we are done till here. Now again we are checking once more that whatever from wherever node we found our string, is that empty. If that becomes empty, there is no more node of that frequency, then we are deleting that node itself. Okay, so these increment and decrement are the method which are main methods which I have explained. Now come to getMax and getMin. These are very simple, chill bro. So see here, getMaxKey, we will first of all check if tel.previous equal to head, that means there is no value at all, so we are returning null. See here, initially we said that head and tel would be only, okay, only two nodes. If there are only two nodes, that means we are not having any stored string already. Okay, so for that reason, if tel.previous equal to head, we are returning null. Otherwise we are returning tel.previous dot strset dot iterator dot next. So we would be removing, we will returning this or whatever string it comes, right? So max we would be returning here just this thing. Okay, tel dot previous thing. Okay, now if see here, this is our utility function delete node which we were using there. So guys, you can see here what we are doing is we are returning from this set any value, any string would be fine, right? If there are multiple strings with same frequency, and of any one of them we can return. That is why we have done this strset dot iterator dot next. So whatever first value, we are immediately returning it. Okay, so for getMin and getMax both we are doing in this way. Now this is a utility function to delete a node, just a simple thing. Let's say we have A, B, C node, right, in a doubly linked list like this. So if we want to delete B, what will happen? Simple, A, B and C. So this would be, if I delete it, its next would be the next of B and its C's previous would be the previous of B, like this. So this is what we are doing. See here, previous node is equal to node dot previous, after node equal to node dot next, and then we are doing this previous node, like A dot next would be after node which is C, and after node dot previous would be A. Okay, so this is what we are doing. So let me execute my code. It is working fine, so I am submitting it. Yeah, so it is accepted code. So guys, we have done everything in time complexity O of 1. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.